Algebra 2 notes. Extension 2.7 use piecewise functions. So first we need to define what piecewise functions are. A piecewise function is defined by at least two equations. So you can kind of see how it fits into this chapter, right? We have multiple equations, kind of like we would with a system. But each of these, so each of the functions we're working with, apply to a different part of the domain. So let's remember that domain is all the things that x can equal. So we're going to have an equation to use when x is one thing. We're going to have an equation to use when x is the other. So that's what we're getting at. So remember, domain is x's. So you can see with our first example of a piecewise function, f of x is, and then you can see it branches off into two different equations, 5x minus 3 if x is less than 1, and then 2x plus 4 if x is greater than or equal to 1. So these are those different parts of the domain. And we're given those two different equations to use depending on what happens. So let's go ahead and try the first one. So first, x is negative 2. So if x is negative 2, that means x is less than 1. So I need to use 5x minus 3. So that means I'm going to say that f of negative 2 is equal to 5 times negative 2 minus 3. And then remember, I'm just working it out on the right. 5 times negative 2 is negative 10. Minus 3 is negative 13. On the next one, x equals 1. So 1 is not less than 1, but 1 is greater than or equal to. So I need to use the function that's 2x plus 4. So now I'm finding f of 1 is going to equal to 2 times 1 plus 4, which is 2 plus 4, which is 6. And then on the last one, x is 7. That's definitely greater than or equal to 1. So I'm going to use 2x plus 4 again. And so I'm finding f of 7, which is 2 times 7 plus 4, 14 plus 4, which is 18. So remember, when we are evaluating a function, this f means I have a function of 7, means that 7 is my input, and the 18 is my output. So inputs are like x, output is like y. So it also kind of gives me that ordered pair right away. I could say 7 comma 18 is my ordered pair. So that's what's going on with function notation. It does not mean that I have to solve for f and divide by 7 or anything. F of 7 is not the same thing as f times 7. So be really careful about that. So for graphing the piecewise function, we're going to be graphing different things depending on where we're looking at on our graph. So first it tells me to graph where x is less than negative 1. So I'm going to go ahead and graph the whole function. And I'm going to do what we did in the last chapter, where I erase parts of it depending on where I'm at. So I'm just going to graph 2x minus 4 for now. So 1, 2, 3, 4. You can see this goes along with what we did for discrete and continuous functions. My slope is 2. And so I'm just getting a quick sketch of this graph. All right. Now the problem is it says that's only where x is less than negative 1. So that means I'm going to have to do some erasing. So negative 1 would be right here for, oops, I did not mean to erase all that. So negative 1 would be right here. So I really only want to graph this part of the function, and it's going to be an open circle. And remember, like this is that part of my function where I'm less than negative 1. So maybe we'll go ahead and do this also. So I only want that to be in this part. So I add the whole line, and then I erase the part that didn't apply. So now my second function is from negative 1 to 2. So negative 1 to 2 is going to be in the pink area. Okay. So now for this part of my function, it says negative 1/2 x. So only in this pink area am I going to graph that. So let's see, I'm at 0, and my slope is -1/2. And I can't really go up 1/2, but I can go up 1/2 and 1 left. So I can kind of stop it in the middle. And so I'm going to connect those. And then my last one says where x is greater than 2. So let's go ahead and put a different color over here. This is where x is going to be greater than 2. So we're kind of taking what we did before with discrete and continuous functions, looking at those continuous functions and different domains for them, and identifying the range. And now we're extending it to piecewise functions. So now it just says 4 when x is greater than 2. So remember, this just means y equals 4. That's going to be a horizontal line, but it's only when x is greater than 2, so only in that blue region. So 1, 2, 3, 4, I would make an open circle here because it says greater than and not or equal to, and then I would have a line that goes to the right. So again, to graph our first one, we graphed a whole line, and then we took off the part that didn't match, and we put an open circle because it said less than, not or equal to, and we ended up with a ray. The part in the middle, I had to just graph in that pink region. So it was easy to go down 1 and 2 to the right to find 1 point, but the other one was kind of weird because it was in the middle of a point. So I might have even wanted to use x equals -1/2, or -1, sorry, which would be right on that boundary line there, and go ahead and plug that in to see what I get. So -1, because remember we're using that function, we should write it down. So we're using the function -1/2 x. We use -1 because that's right on this line here. -1/2 times -1 is a +1/2. So that's kind of how I got this point right here, by just trying to do the slope but having to stop in the middle of it. And then when x is greater than 2, so over in the blue region, I knew that I had to have a horizontal line, y had to always equal 4. So that is a piecewise function. This is all we have for notes on piecewise functions. Please ask questions if you still have them, and there's a few homework problems for you to try.